architecture and the recommendation for the deployment in production environment. Okay, so let's start by the architecture. A CEPH architecture is composed in production environment is composed by the CEPH nodes, okay, the OSD node. Those OSD nodes have inside even some hard drive, which can be SSD or mechanical hard drive, or NVMe hard drive. All those nodes are inside of the OSD nodes, okay. And those OSD nodes should be connected, let's say in production environment, should be connected on two networks. The cluster network, this cluster network will be used for the rebalancing or self-monitoring of different OSD nodes, and also some action or verification action. Okay, so all those actions will be performed through the cluster network only. Okay, so you should provision a very good throughput, at least 10 gig throughput for this cluster network. The second network on which of the cluster with the OSD node will be connected is the public network. Okay, it is a public. This public network should have a throughput of at least 1 gig. Alongside that, we have the other node, which is the monitor node. The monitor node is which you have the monitor node daemons and the manager daemons. Both daemons should be inside the monitor nodes. Okay, and in production environment, you have at least an ODD number of OSD nodes. For example, 3, 5, 7. This kind of number of monitor nodes should be inside your production environment. Okay, not 2, not 4. Okay, you should have at least 3 nodes, OSD nodes inside your cluster environment. After that, you have another node, which is the metadata server for the file system for the CEPH. If you want to provision some file systems, backend storage up to your client, you have a node which embeds the metadata server nodes. Okay. Daemons. This one, and this metadata server should be connected inside on the public networks. Very important. And all those nodes, the metadata server node, the monitor node, and the CEPH nodes, all those nodes will be your cluster, your self-storage cluster. Okay, so it is these nodes that the part of your CEPH cluster, okay, nodes. And after build your CEPH cluster, okay, storage node, you can have some gateways, okay. So gateway will provisioning the backend and another backend storage to your client. For example, if you want to have an Amazon S3 or Swift backend for the object storage, for example, you should have this Windows gateway, for example, that you can plug to your cluster, okay, through the public networks. You can have also an iSCSI gateway if you want to build this kind of this iSCSI protocol for the network for your clients, okay. And through the public network again, your client could be connected in order to receive or to retrieve or to set the different data inside your cluster. Okay, so your client should be connected on the public networks, and the metadata server, the monitor server will be connected, and also the OSD node server should be connected on the public network. And only OSD should be connected in 2 networks, the public and the cluster networks. After talking about the architecture, let's talk about now the different hardware recommendations in the production environment. We will share our advices about advice points. Okay. So the hardware recommendation for the cluster configuration inside the production environment. You will first talk about the central processing unit, the CPU, okay, across this, we'll talk about this for the metadata server for the monitor, and also another point you will be talk about CEPH. For the metadata server, you have to know that it's a very CPU intensive node. Okay, so you should provision a very good level of processes in use for this node. Okay, for example, you can have one secret CPU, but at least four cores for this node. You should provision it for this metadata server nodes. Concerning the CEPH, how the CEPH should perform the self monitoring regarding our OSDs, because it is the OSD that take care of our OSD. So at each time, the OSD take care of another OSD and try to report if any other OSD is down or is in the cluster. Okay, and our self-OSD daemon also should perform the workload of rebalancing, the self-rebalancing or self-healing action inside the cluster. So all those types are CPUs, a high CPU workload. So the recommendation, the general recommendation is for one core for if you want to perform a archive action for this cluster, for cluster, sub-cluster, you should have one core for each CEPH. Okay, but if you want, for example, for your cluster, you should use your cluster for the block storage and so on. You should have at least 2 cores for each CEPH daemon inside your cluster. Very important. Concerning the monitor, it doesn't demand a very user CPU workload, so you don't have to provision a high level of your CPU to these nodes. Let's talk about the random access memory, right? Okay, just to fix some information, you have a CEPH vocabulary. When you talk about a tiny cluster or the modest cluster, you talk about a CEPH cluster that you have only not more than 50 OSD inside the cluster. But okay, by this way, for a monitor, for example, if you have a modest cluster, you should provision for regarding the RAM on this node. You should have to provision only 65 gig of RAM for this node, monitor node. But if you have more than if you have in case of a large cluster, okay, you can provision 128 number gig for the random access memory. Okay. Concerning the metadata server, it is recommended to have at least 1 gig of RAM for the metadata server. Okay. Another point concerning the CEPH, as it is the data storing, the CEPH should have at least per daemon, what's the daemon? You should have at least 4 gig what's the daemon. Okay, later you could cover this subject because the CEPH daemon has been now governed by the boot store at the default bucket storage for your cluster. Now let's talk about the OSD. Okay, the hard drive, which can be the mechanical hard drive. It can be also the SSD for the storage. Okay, so let's talk about our general recommendation for this point. You should know that if you intend to have OSD inside your cluster composed by only mechanical hard drive, both hard drives should have the same size. And the recommendation size is 1 terabyte. Okay, don't use a cluster where you can have 1,500 gig of RAM of OSDs. Okay, and another hard drive which sized by the 1 terabyte. It's not recommended. It will not recommend it. Okay, only one size should be provided for mechanical hard drive. Okay. Concerning the SSD, The recommendation, if you want to have some SSD inside your cluster, and the recommended because of SSD is more faster, okay, you should use it as your journal inside your cluster, okay. You just use your SSD drives as your journal inside your cluster, okay, and at least for one SSD, for example, SSD which have a size of 200, you can split it in a stable volume groups, okay? And each volume group you can use as your journal for your mechanical hard drive. By this way, you will improve the performance of your cluster, okay? So use the SSD as your journal. Later you cover this one how to configure a journal inside your cluster, okay? And another point, don't split at the backend storage. Don't split or don't gather the SAS, SSD, and mechanical hard drive inside your cluster. Don't do this one, okay? Just use one type of hard drive or SSD inside your cluster. Don't gather the different types of this or SATA, SAS inside your cluster, okay, as storing data, okay. If you do that, the more speed, the hard drive which is not faster will impose the speed up to the whole cluster, okay. Now let's talk about other networks. Concerning networks, we already talked about this. Concerning networks, you should provision a network of at least 1 gig for the public networks, and for the cluster network, you should have at least 10 gig for the cluster network. Okay, so don't forget that point and try to provisioning this one in production. It's mandatory, because when you will lose one hard drive, because in a large cluster, it is an expectation. You will lose some hard drive in production. Very important. You have to keep this point in your mind. And when this hard drive will lose, all the data inside the cluster will be rebalancing in flow of the networks. And if you don't have a very good throughput of networking for the cluster network, your performance, your client will suffer of slowness inside your cluster. It's very, very important to have a good throughput of cluster inside your cluster networks.